flat plate made of cast iron is exposed to a solar flux of 600 watt per meter square at an ambient temperature of 25 degrees centigrade. Assume that the entire solar flux is absorbed by the plate. Cast iron has a low temperature absorptivity of 0.21. Use Stefan-Boltzmann constant is equal to 5.669 into 10 power minus 8 watt per meter square Kelvin power 4. Neglect all other modes of heat transfer except radiation. Under the aforementioned conditions, the radiation equilibrium temperature of the plate is. So we need to find out the equilibrium temperature of the plate in degree centigrade. Let's look at the solution. This is the scenario where a cast iron plate is exposed to a solar flux which is Gs of 600 watt per meter square. It is also given that the ambient temperature is 25 degrees centigrade. Converting that into Kelvin will give us 298 Kelvin. We also know the value of absorptivity of cast iron, which is alpha Ci, which is 0.21. Now, analyzing this condition, under the steady state of cast iron plate, it is important to note that the heat absorbed by the plate due to solar flux is equal to net radiation heat transfer between the plate and ambient temperature. Under this condition, since the sky radiation is concentrated in approximately the same area on the cast iron plate as that of surface emission, we can consider the absorptivity of cast iron plate, which is alpha Ci, is equal to the emissivity of cast iron plate, which is 0.21. For equilibrium temperature of the cast iron plate, the heat transfer per unit area due to radiation should be equal to the solar flux. So the heat transfer due to radiation is given as epsilon into sigma into T power 4 minus T infinity power 4 is equal to 600. Substituting the corresponding values of emissivity, Stefan-Boltzmann constant and ambient temperature and simplifying, we get the value of the equilibrium temperature of the plate as 218 degrees centigrade. The accepted answer range for this question is 210 to 225.